From ContainerDays Hamburg, this video is proudly presented by DAX IT.
Today, I'm forking myself from moderator to speaker to share a little story or a little research on evolving the edge, AI, CI, hardware in the loop for embedded. A disclaimer up front, I was very ambitious when I was at the Embedded World in Nuremberg in March. I thought, well, we can make this happen, everything which I pitched. And the reality is like, it's a little more complicated, but I still wanted to share what I researched, what I learned, what I developed over the couple of last weeks, months, because the industry is moving so fast. So this is me, I'm Michael. I go as DNS Michi online if you want to connect or reach out for a coffee chat or for learning together in public. I work as staff developer advocate at GitLab. This is the note, this is research, this is not about the GitLab, the product today. Anything which I show today is not on the roadmap. But let's dive in from what are common problems with embedded development. And there's certainly a lot of challenges in that regard. You need to generate code that aligns with hardware specifications, internal architectures, there's maintenance involved, modernizing code can get quite complex with like C or specific other languages. Security is a topic. Production hardware on the other side can be very expensive, and it might need smaller platforms to kind of iterate and figure out if there is a problem faster and not just wait 2 days or maybe a week for a simulation and then figure out, oh, actually the linter or the security thing failed. There's also the requirement of proprietary offline environments, which makes it even harder to consume anything which is on the internet, especially AI, for example. And a lot more with cross-compilation, limited debugging options and whatnot. So it's a really challenging environment. And the idea for hardware in the loop demand comes across from like, this is a statistical number which I found in a report. It's like 40% of embedded projects run behind schedule. And most often it's attached to debugging hardware-specific issues. And the problem is like it's in an air-gapped environment, has security or intellectual property, which needs to be protected and cannot leave the local network. So you cannot just send the codes to the cloud and then some magic happens. So it's really like it needs to happen in that environment where the errors are happening. Sometimes they are cryptic, specific. So the idea would be maybe there's a way to test early on a similar or same platform that exists in production. The other thing with AI is on the other side is there was this embedded AI paradox. Like the problem is embedded developers would benefit from AI assistance. So to get insights into complex hardware constraints, specifications, designs, boards, whatnot, cross-compilation, and even real-time requirements. The problem is they might not be able to benefit from that because of that air-gapped environment, the proprietary systems involved, where there might not be a plugin for AI, for example, and they cannot send the code to the cloud. So the idea would be to say, well, maybe there's an opportunity or possibility to use a local AI somehow on the edge. Now, why discussing this now? I thought of like, well, there is the idea that you can have a production platform or architecture at low-cost environments, like in a home lab. You can run a single board computer like a Raspberry Pi, which is affordable and can help simulate the production environment. On the other side, you can connect microcontrollers, simple like an Arduino Uno or Raspberry Pi Pico, but also ESP32. Kind of similar ways to run firmware on a microcontroller and actually test it on a low-cost hardware. The other side, which is happening right now, is that edge AI hardware and those developer kits are more mature, and specifically the NVIDIA Jetson Orin, which has a nano super developer kit, which I was fortunate to get. It gets affordable, it gets more mature, and we're able to even run LLMs on them. And the third thing that's currently happening in the industry is that those LLM capabilities happen at smaller sizes. So you might have seen the 70B models, the 32, then there's like 7B, 3B, and now we have 1 billion parameters and even 270 million parameters, which is roughly, I think, 300 megabytes to download and run in the GPU VRAM, which makes it possible to maybe run them on embedded hardware. So those three technology curves can maybe just converge into making something that was previously impossible now possible. So from a foundation perspective, I want to first look into CI with hardware in the loop, and then figure out how we can inject AI into that. And in order to do that, I created my own research setup. So this wasn't built in a day. It was an iterative way of the last year, I would say. And for this setup, I do have GitLab runners. I have a GitLab server. For this demo or for this talk, I will be just using gitlab.com, so I can access my hardware at home. And the GitLab runner specifically runs on a Raspberry Pi 5, has 8 gigabytes, and it also has an NVMe attached SSD, which is important for speed because the SD card will die if I run too many CI jobs on that. The target is a microcontroller. In the picture, it's a blinking Pico W, which has Wi-Fi to that. And it's a good example to get learning and playing with a microcontroller. There's also the NVIDIA Jetson in the picture, which we'll come to later. And I think everyone can build that setup. So if you want to follow along, all the resources are on the slide deck. Slides are already public, so you will see a QR code at the end, so you can reproduce everything that I'm sharing today. Now for the setup, I wanted to automate things because I'm a lazy person. And I looked into Ansible, like installing the base operating system. The most important part for embedded development is you need to have a compiler for the ARM platform in that regard, because the Raspberry Pi operating system or platform uses that. So there's a specific GCC compiler package required, and libraries or dependencies for ARM and also for USB. The idea is to build directly on the host system, so you can then connect to the attached hardware and flash the firmware directly from CI/CD, and then attach the serial UART via USB modem and read the output immediately. This is the base operating system. The next step is to install the GitLab runner, and this might feel a little overwhelming, but in essence, what it really does is it installs the package repository and the packages, and then starts with the runner registration to the GitLab server. It uses the new flow, which works for group, project, and instance runners if you're using a self-managed instance of GitLab. And there's also support for multiple executors, so I can run my jobs directly on the host, like on the Raspberry Pi, but I can also spawn a Docker container and execute those. These Ansible playbooks are newly developed, so they work for me. But you can also check them out, modify them, fork them, use them for your own environments. The idea really is to automate everything, and when I set up a new Raspberry Pi in my setup, just run Ansible and have that available. To fully register the runner to the server, there's an additional procedure needed. Use the API to create the runner, receive the registration token. There's a community module in the Ansible environment available, which then exposes everything that we need. And the second step is to run the runner CLI to fully register the GitLab runner on the Raspberry Pi with the fetch token, the executor. And if I use, for example, the Docker executor, I also want to define a default image, which is small, so that the pull doesn't take that long on the Raspberry Pi. And then it fully works. And in order to kind of show that it works, this is a view from the group page. I do have two different runners registered here. They expose different tags. So one is using the Docker executor, which got an additional tag for Docker. The other one runs natively on the host, and all jobs or GitLab CI/CD jobs that use those tags for embedded Pi5 8 gigabyte AI will then be picked up specifically by that runner. And so I can make sure that only the jobs run in that environment. The first practical test worked fine. There are a lot of things you kind of need to configure for compiling the firmware, setting up the Pico SDK, so the dependencies and the libraries, which is shown on the left-hand side, like abstracting that away in a CI/CD template, and on the right-hand side, extending that or using that job template. and then doing the actual job. So you will see like building the firmware with caching. It checks for a CMake file, then runs CMake make to build the artifacts. And the artifacts then can also be exported or exposed, uploaded to the GitLab server, and then you can use it directly on the hardware again. So whether this job runs in Docker or on the host directly, it doesn't matter, because the artifacts are passed in the pipeline, and you can immediately use them for flashing the Pico via USB. When I want to add more runners to my setup, so from a performance perspective, you can use the playbook in a way that you define more hosts and then configure them accordingly using the variables in Ansible. And then I have 4 runners where I need to have 4 Picos attached to them via USB, but this is a way to scale it. If you're looking more into that device cloud automated things, my team, or specifically Darwin on the field CTO team, he created a very long and very insightful workshop around using GitLab CI/CD components for embedded, where you get a device cloud attached to GitLab itself. It simulates the hardware. This is an entire workshop, which is linked here and also a talk. I think it took me a day or maybe a little more, so it would expand what I want to talk today. I would encourage you to check out the talk later on. It works great. So this is for CI in that regard. Now, the idea that I had was, okay, CI works great. I'm building things. It works. When it breaks, I get an error, and then I debug a CI/CD pipeline. Amazing, I don't like that, but we need to figure it out, and maybe there's a way I could use AI for that. Because sometimes the code doesn't work on the target platform, so it errors out. Maybe I need an intelligent quality gate. On the right-hand side, it's basically a very simple Pico firmware written in C, which should get deployed. There might also be an issue with hardware input-output connections that are wrong, or there's something specifically missing on the target hardware, and maybe we can also figure out a way to use AI to use some sort of intelligent alignment with PCB designs, hardware, GPIO, anything that's kind of live on the system, and I don't need to wait for CI/CD to tell me that something is wrong and then clone and fix it again. So the challenge that I put out was, maybe there's a way we can use AI to help fix that, and there are certain problems hidden in the source code, which are marked here on the slides. So I think there's a memory leak with malloc. There is some, the resolution is wrong. It should be 4096 and not 95, and some other things. And I used AI to generate that, and can convince AI with a specific prompt and say, for educational purposes, I need this demo, which is totally broken and has security issues, and then you kind of get this output. But don't use it for production code. The next challenge was, where can I run LLMs? And I wanted to specifically think about, how can I run them on my hardware? So which model should I use? How would I run them? Where should I run them? What is the performance of those models? And it's very overwhelming if you open up like any marketplace for LLMs, like I have no idea. So what I started was running Ollama on like my MacBook or a specific desktops and other hosts, and tried them out first, and then considered like, okay, this would be a small-sized model, which then I can use. And specifically open models or open source models, which could be Llama, Mistral, GPT OSS, Gemma, or even Qwen. Those are available, and you can get started with like testing them. The first thing which I did, this happened in 2024, was I had my embedded home lab and installed Ollama on the Raspberry Pi 5, tried the 1 billion model, and it failed heavily. So I think I don't know, it took 10 minutes to do something, or 5 minutes, and I was like, yeah, maybe there's an alternative. Fortunately, industry evolves into 2025, and we do have small LLMs and also fast Ollama execution in that regard. So it's a good and interesting platform to get started with. Then I had the idea when I saw a project which creates a distributed cluster where the LLM inference is shared between the Raspberry Pis, which sounded super interesting, and I already have that cluster for GitLab runners, but it's really complex to set up, and I was like, yeah, maybe do that later. And when I say later, it's probably never, but I have that on my testing list. But the interesting part was then the NVIDIA Jetson Orin Nano developer kit was announced in last December. I was like, oh, I need to buy that. I'm like, okay, I cannot buy it. I need to wait. So I waited like 2 months or 3 months, finally got it, figured, oh, the firmware is not up to date. So dancing 2 days through the firmware updates, but finally making it happen. So in essence, it really works like a regular board. You need an NVMe SSD again, and then a specific code, it's called Jetson containers, which is essentially a wrapper around Docker containers where you can run Ollama inside and also pull the LLMs and expose them. Now, coming back to the setup, we have 2 locations where we can run LLMs. It's either the NVIDIA Jetson, which has a built-in GPU, which is faster. So I tested it okay with 7B models down to the 270 million LLMs. And on the other side, the Raspberry Pi 5, which also works natively but has CPU only. I mean, there are videos on YouTube where there was the big GPU or graphics card attached and the small Raspberry Pi. This probably works as well, but you can still only use the Raspberry Pi nowadays as well. I also considered Ollama alternatives, so Ollama exposes the LLM with an API, and VLLM is considered faster for parallel requests on a production server if you consider that. Now, the idea that I had was I want to run the LLMs on the CI runner host directly, so it's on the same host, the same network, and I can take advantage of that immediately. So I used Ansible again to install Ollama directly on the Raspberry Pi, some steps with installing the packages, systemd and whatnot, and also pulling the required model that I wanted to use, in that regard, Gemma 3 with the 270 million parameters, and then used Ansible just to tell me that I installed those specific models. Now I know I have these models available. How can I use them in CI/CD themselves? And the interesting thing that happened was someone else had the same idea as I at the Open Source at Siemens event in 2025, which I attended in Zurich in June. And they were actually building this specific thing with running LLMs on a GitLab CI runner, where they also have more GPU power attached to that. But I was curious, well, does that idea maybe work with my Raspberry Pi setup with the CPU only? Because I know I tested it somehow. So I was like, okay, let's try it out. And in order to fully understand how this works is when you expose a CI service in GitLab, it's basically, it spawns another container, which uses the, I think it's a bridge network to the actual CI job container, and you can actually use that service which is exposed. And the documented way is running MySQL or PostgreSQL database servers or even Redis, and you can just spawn the Ollama container there, expose it as Ollama service, and then use that endpoint in the communication from in between CI/CD. So what I did was I created a small script which passes the source code into memory and then sends it over to the LLM and says, and uses a simple prompt and say, please analyze the attached source code. Please tell me what's wrong. Provide me with a summary, just to see if this is actually possible. And I also asked the script, or I asked AI to generate me a script. Please tell me the duration and everything else which is important. So the first run with like 2 files which were uploaded, main.c and the CMake file, it ran in 28 seconds roughly. And it was able to identify the problem. So the formatting on the screenshot is not great, but you can see the history in the GitLab project, which is linked at the bottom. And it was able to determine that there are some issues in the source code, and I can do further things with that. Now the runtime was 28 seconds, and sometimes it's also 10 minutes for some reason, so I haven't figured that out yet on the Raspberry Pi. but probably something is burning in Nuremberg right now. So I thought, like, maybe I can run the LLMs remotely on a more powerful GPU, so like the NVIDIA Jetson that I have available. And in order to bring up Ollama on the NVIDIA Jetson, you need to run Ollama in Docker. It exposes the port 11434, and you can test that from the GitLab CI runner host, the Raspberry Pi with curl, target the port, and there is an API endpoint called tags, which then lists which models are available in that Ollama instance. You can also like pull the models, configure that, and not only use that in a CI/CD environment, I could also combine it with, for example, I have Home Assistant, which could also use local LLMs in that setup, or anything that comes to mind you can play with. The NVIDIA Jetson was, I think, 250 USD, so the setup is roughly 300 USD if you want to reproduce that, which is more affordable than too much money. The outcome was, when I run the same script, but with a different endpoint using the NVIDIA Jetson in that example, was it took 12 seconds or 12.5 seconds, which was roughly 2 times faster than the Raspberry Pi. And it motivated me to continue testing and building, because I was like, yeah, I not only want to have the analyzers in CI/CD right now at this stage, but I also maybe want to use agentic AI or flows, MCP, like tool calling, letting AI build the code, agents, and then figure out how to fix it. Fixing and editing is still challenging, or even like making LLMs use the right tools, which is my current problem, but we'll come to that in a bit. The idea would be that the flow is the developer pushes the changes, the CI/CD job then triggers the analysis. There's a specific tool called read the source files. Then the source is sent over to the LLM provider with the Gemma models loaded in. The LLM returns with the issues and suggestions, tries to build the source code eventually, generates the fixes, make sure that everything works, sends that back to CI/CD, and if everything is successful, we can then flash the firmware if everything works and get the serial feedback, which could be a logging output or anything that gets passed back from the microcontroller firmware. So this was the general idea of the model that I tried to build. Problem was my first script wasn't that successful, so I exposed the tools, everything seemed to work fine, but it couldn't find any issues. Then I ran another analysis and figured out, okay, the LLM prompting isn't that good. Maybe I should find a different output, like the response passing. And you kind of need to generate an output format from the LLM, which then gets passed into another thing. So it's not that great yet. And it also needed proper MCP implementation, which means client-server architecture using the MCP libraries and whatnot. But it was a first start how to get going. And yeah, I shouldn't work on talk demos the evening before, but yesterday I was like, maybe I can make this happen somehow still. So I created a short new script, added some enhanced tools, used the MCP library for the agent communication, and it was able to still analyze everything. But the problem right now is the tool calls are not fully working. I can quickly show you how this works in reality. I'm not sure if the live demo will finish by the end of the talk. But what I have here is my GitLab project with source code, and I also have it checked out locally. So you can see the source code here. And I prepared something which is hopefully fixed. Then we kind of simulate a change now. Then hopefully the Wi-Fi works. Can create a new merge request. And there is a summary, maybe not. Sometimes, yeah, okay. And create a merge request, which then triggers the pipeline. And we can follow along the pipeline. Now it takes a little bit because my Raspberry Pi at home needs to pick up the jobs, but the idea is here that it does some pre-setup, then analyzes the source code, uses agentic AI to fix it, and when successful, build the firmware, run security scanning, and then run test in Flash. And while this is running, I will continue. Should have probably started this earlier. Okay, so I just wanted to make sure that this is not a fake screenshot, but this is actually something that can be tested and can be used. The only problem is sometimes the duration even takes for this specific analysis like 4 minutes. And when you start it again, it might get slower. So scaling that in horizontally with more runners, more CI/CD hosts, can be a good idea for faster development. So what I tried to build here, what we built here is like maybe agentic AI evolving the edge, providing those possibilities. Right now, what I consider possible is like code analysis, syntax checks, quick fixes, and build validation, sort of. But what I also consider something that we should explore, could explore in the future, is like code modernization, which is a huge task in like analyzing and fixing large repositories, maybe even like rewriting certain things in a different language, performance optimizations, generating documentation, which also includes architecture diagrams and designs and whatnot, test generation, and also security scanning. And the idea would be to use, for the lightweight tasks, the smaller models or the smaller hardware. For the heavy tasks, maybe the Jetson, or maybe there's also cheap other hardware in the future that we can use for that. And on the CI/CD pipeline side, we can have fast jobs for the analysis, for build validation, which uses tool calling in that regard, or the intense jobs for deep analysis, for generating certain things, and then combine that in the final CI/CD output. The open question is like, does this make sense? Or what is Michael talking about here? Well, I didn't test it for scale, so there are no benchmarks attached to that. There's also quality assurance needed with regards to, are those smaller models enough for the almighty knowledge about code, or what happens specifically in embedded development? Is the LLM enough? How can I inject live context, like using RAG or MCP, or even like agents talking to other agents running on embedded? And also the understanding of embedded in general, like hardware specification PDFs, which then somehow use OCR scanning and put that into, or even like a PCB design, board designs, drivers, and so on. So I couldn't test that yet, but it's still, I know it's a challenge, and it would be super interesting to have that available as well. Customers have been asking around, maybe I can upload an oscilloscope waveform data test result and also some logs, and then kind of combine that and provide that as an early result for anomaly detection. And another customer I've been talking to was, or they're building binoculars, and on that hardware, they kind of detect when a bird is coming into view. They use own-trained machine learning models on embedded chips. Maybe there's a way to kind of reuse the idea of these trained low-power models in a sense of running them on my own CI/CD hardware. That being said, I asked AI to generate me a summary of my setup from that project that I created. So this could be something that works in the future. I know it's a little confusing, but it certainly shows how to build your own setup with CI/CD, with AI, with the different environments, and then being able to test the firmware, hopefully in a similar environment, how production works. That being said, these are the resources. So there's a QR code which links to the slides, which has everything. So everything I know is on these slides. Nobody knows about this yet because it's new learnings. The use cases project, the Ansible automation. Connect with me on LinkedIn if you have any questions or just want to connect. I will be here all day moderating the K2. Otherwise, let's quickly see how far we got before I finish. Pipeline is green here. Oh, yeah, failed again, but you can see it attempts to query the Olama service. So it's running, but there's still work to do to make it work in a proper environment. But I hope I could inspire you for your own exploration in the embedded development world with CI, with AI. And that being said, thanks for your attention. Shoot me with questions now. The first question is, how did you flash the firmware from the Raspberry Pi on the Pico on Docker? I ran into the problem that I needed to map the device for the serial attached USB into the container. So my idea was then, which I showed in the beginning, that I built the artifacts in a Docker container, upload them to the GitLab host, and the Flash job, which actually runs natively on the Raspberry Pi, which then has access directly to the USB device. Have you tried code-based indexing to provide more context to the AI for better insight? I have not, but this is something I totally want to try. Code-based indexing requires some knowledge graph or some mechanism or some tool, which likely needs to sit in the same environment, running in the network. And I think it will totally speed up the analysis and also helping the agents understand what's actually currently going on and totally make this worthwhile. This is actually, this is a great idea. Maybe I'll do a follow-up talk next year or share some research on that, because at GitLab, we are also building such a knowledge graph right now. So it will be available in the next weeks or months, which then can provide even more insights. Thanks for the question. How do you monitor, double check the adjustments applied to your code by the AI? Can you roll them back if you don't agree with its modifications? So right now it's generating them in CI/CD. It doesn't do a git commit yet, but you could, one way you could do that is you push the git commit remotely. And if you don't agree with the modifications that it did, you could revert the git commit, which is a transaction log on its own, and specifically work with that. Monitoring or double checking that, run the build job again, or run a scoped smaller check in order to ensure that the code that gets generated with AI is fully compliant with your requirements. You could even use custom instructions on the side to say, I need code specifically targeted on that. I think in Cursor it's called custom rules and so on, so similar, using that in the system prompt. Will AI evolve into an operating system to control all devices? I'm not sure. I still want to be in control at some point, so I think human in the loop is important, and also that review process, but I think you can maybe see it similar to infrastructure as code or the entire DevOps evolution, I would say. In a way it can help us automate stuff, get a better understanding, but there still should be maybe a way that I'm the operator of the operating system at some point. So I like the idea. Now I'm getting a little confused. Questions? Any waveform analysis for anomaly detection is problematic. Could this way of generating code become a problem for safety? I'm completely honest, I'm not really deep into waveform analysis, so maybe we take this offline and chat about this. Anything else here? No, this was all. Thanks for the great questions. I will be around today here, so please come by in the breaks if you want. Yeah, and thanks for joining again.
From ContainerDays Hamburg, this video is proudly presented by DAX IT.